Let's jump into more geometry today. So now we are in section 11.3, more about angles. So we can classify angles just like we could classify polygons, vertical, supplementary, complementary, parallel lines and angles associated with them. So let's talk about what are vertical angles. Vertical angles are angles that are directly opposite one another. So in this picture here, you see angles 1 and 3. Sorry for that delay. Okay, so you see angles 1 and 3. These guys are vertical angles. And then angles 2 and 4 are also vertical angles. And what's special about vertical angles is that they are congruent. So if this was 60 degrees, this would also be 60 degrees. Um, and if this was 120 degrees, this would also be 120 degrees. Supplementary angles are angles that make up a line. And we know that a linear angle is 180 degrees. So the sum of these two angles is always going to be 180 if they make up a straight line like this. And so if you know one of the angles, you can find the other angle by just subtracting from 180. So again, this word supplementary means that the angles add to be 180. Supplementary angles add to be 180. Complementary is a word for angles that add to be 90 degrees. Okay, so complementary, 90 degrees, supplementary, 180 degrees. So in this case here, if I knew I had a right angle, this is a notation for a right angle. That means 90 degrees total. And you need one part of the angle, you would know the other part is 90 minus the part that you know. Transversals and angles. And so these are more definitions of all the different kinds of angles. We have interior angles. Interior angles. Those are angles in between two transverse, in between the lines. Okay, so we have a transverse line that's cutting through two lines. And the interior angles are these guys. Notice they kind of seem like inside, right? So interior, in between the two lines. Those are the interior angles. The exterior angles would make sense that they are on the exterior of the lines. So these guys on the exterior and these guys are on the exterior. Those are exterior angles. Alternate interior angles are angles that are inside, but they are alternating. Okay, so they're on opposite sides. So like these are alternate interior angles, and then 4 and 6 would be alternating interior angles. So they make like a Z. So if I had this situation here, these guys would be alternate interior angles. Alternate exterior angles, the same thing except the outside. So like 3 is alternating with 8, and then 1 and 7. So those are some definitions. Again, interior is in between the lines, exterior is the ones outside the lines, and the alternating part is that they're on opposite sides of that line. Cutting through. If any two distinct coplanar lines are cut by transversal, then a pair of corresponding angles, alternate interior angles or alternate exterior angles, are all congruent if and only if the lines are parallel. So if you notice, parallel again means that they're like this, right? So in which of these pictures are the lines parallel? A or B? Which ones have the lines parallel? Hopefully you're saying B. In this case, if the lines are parallel, then I have all these properties that are true. So I have the fact that the alternate interior angles are equal. So 5 and 2 would be equal to one another. 4 and 6 would be equal to one another. And likewise, 8 and 3 would be equal to one another. And 7 and 1 would be equal to one another. So just to put some measurements out there, say that we knew that this guy was 60. That means that the one that's vertical angles too, you can see that this would also be 60. And then because these two angles make a line, this one would be 120, which means this would also be 120. And then this is alternate interior, so this would be 120, alternate interior, so 60, and then vertical, so 60, vertical, so 120. So you can easily find all of the angle measurements. You just know one if the lines are parallel. The sum of the measures of interior angles of a triangle is 180 degrees. If ADC measures 50. What are the measures of the other angles of the parallelogram? Excuse me. Okay, so it's a parallelogram. Parallelogram means that the lines are parallel. So this is parallel to this. So if this is 50, this is also 50. Oh wait, I'm sorry. No, it's not. I did an alternate. This one is 50. The alternate interior. This and this are equal. So then these two are on a line together. So that means that this is 180 minus 50, which would be 130. And then that means this one is 50 and this one is 130. And then let's see this one, which makes sense. And then let's see. I know that alternate interior angles are equal, so that's 50, which means this is 50, which means this is 50, which means this is 130, which means that this is 30, and then this is 130, and then this is 130. Okay, so if you look at just the parallelogram, you can see that there's this pattern due to the transversal and the alternate interior angles being equal. What do you notice? You notice, hopefully, that the opposite angles are equal to one another, right? And that these angles that are along the same side add up to be 180. So that will be a pattern for parallelograms. Again, that works if it's a parallelogram. Explain why 1 plus 2 equals 180. So this is kind of what I just mentioned. So the reason that 1 plus 2 equals 180 is because this, so I know that 3 is going to be equivalent, this guy is going to be equivalent with this alternate exterior angle, right? Which is a vertical angle from angle 1. And so because of that, angle 3 and angle 1 are the same. And then angle 2 and 3 are supplementary since they make a line, which means that angle 1 and 3 are supplementary. So that's why we know that they can equal 180 degrees. Supplementary means add to be 180, or they're on the same line. This is a theorem. The sum of the measures of the interior angles of a convex polygon. Remember, convex means it doesn't like come in on itself. Is n minus 2 times 180. And if it was a regular polygon and you want to find the measurement of each angle, you would just divide by n. And then the sum of the exterior angles is 360 degrees. So find the measure of the interior angle of a regular decagon. A decagon that has that prefix dec, which means 10, so 10 sides. So according to that theorem, we do n minus 2 times 180. And so I do 10 minus 2 times 180, which gives us 8 times 180, which gives us this. And then if I wanted to find the measurement of each angle, well, a decagon has 10 sides and it has 10 angles. So if I, hold on. So if I wanted to figure out I would divide by 10 to give me the measurement of each angle. And just a little, how recording? Find the number of sides of a regular polygon, each of which whose interior has measurement of 175 degrees. So since each interior measurement has an angle of 175 degrees, then I could find the exterior angle by subtracting from 180. Because if I have the situation here and I have an interior angle, if I was to draw the exterior angle, these two guys need to add up to be 180. So if I know the inside one is 175, that means this exterior angle is 5. So if I take all of them together, would add to 360. If I divide 360 by 5, I get 72, which means there are 72 sides. That is like almost will look like a circle. Okay, so that's it for this section. You have some practice problems in section 11.3. Attempt them, and as always, please reach out if you have any questions.